Okay, let's continue the lecture. In the previous lectures, we talked about that there are a lot of ways to compromise a computer. Now, what they can do with the compromised computers. So we have mentioned that there are two factors of computer security problem. So first, there are a lot of buggy software, or there are a lot of vulnerabilities. Then the second, money can be made from vulnerabilities. Okay. So there are marketplace for vulnerabilities, where vulnerabilities can be sold and bought. There are also marketplace for owned computers. So this is the current state of computer security. So in the early days, right, so the compromise of computer is a bragging right. Now it's a way to make money. This is why malware like ransomware are so popular. Okay, with a compromised computer, so the attacker can steal IP address and bandwidth. So when you steal IP address and bandwidth, normally you are creating a botnet. The attacker is creating a botnet. Okay, so the attack's goal is to look like a random internet user. So this is make many detection to be very difficult because those are legitimate distributed users. For example, if they use this to launch a distributed denial of service attack, so this is very difficult to prevent because they all come from random sources which are actually legitimate. Okay? So they can use the IP address of the infected machines for spam. So there are a lot of botnets which are used to send the spam. So according to spam analytics, 1 out of 12 million pharmaceutical spams will lead to a purchase. 1 out of 12 million. So if you think about this, right? So the cost of bandwidth will far exceed the benefit from the purchase. So this can only be done by using others' machine and the bandwidth. Okay, 1 out of 260K greeting card spam will lead to an infection. So this Christmas greeting card. They also can do the distributed denial of service. So this is the rough cost to launch a distributed denial of service. For 1 hour, it will be like $20. 24 hours, that'll be $100. Okay. They can also launch the click fraud by actively clicking ads. So Google is expert in the prevention of the click fraud because this is directly related to their business model. Okay, they can also still use a credential and inject ads. For example, if you compromise a machine, you can install keylogger for banking, web, and the gaming password. So the gaming password is actually a very interesting target, right? So you have all kinds of investment in your game gears. So here is an illustration of this process. So the user will request a login page, and the bank will send in the login page. Then malware will inject the JavaScript. For example, if you visit bankofamerica.com, so the malware knows you are visiting a bank website. It's going to inject the JavaScript and hook into the login process. For example, in the login process, right? So you have a username and the password. then there is a button say log in. So the JavaScript will hook into the login button. When you click this button, JavaScript will look for those two fields and send this data to the attackers. Okay, so the user submitted information is copied to the attacker. So about injecting ads. So there is a related problem. So the ISP. So some ISP, they actually is going to inject ads into their subscribe. Okay, let's assume this is a mobile ISP. So you are browsing the internet with your phone. So when you connect to the cell tower, so you have data flow in this link, right? So you have web access. So the ISP server, if they can detect that you are using HTTP, they can inject the ads into this web page. This has happened before. Okay, it can also be used to spread to isolated system. So isolated system sometimes is called air-gapped. Okay, you have a system maybe inside a small network. But this small network, so this is the networking gear, is isolated. It's not connected to the internet. Okay, it has its own internal system. So normally air-gapped system is also locked. It has very strict access control. So only certain user can access the system. So this will prevent the attacker from physically access the system. Okay, so an example of spreading to isolated system will be Stuxnet. So the Stuxnet is a state-sponsored malware which targeted the nuclear refinery, right? So because it's a very important system, so it is air-gapped. But how did they get it into the system? Okay, so they are basically using this USB key. So they dropped a number of USB key loaded with malware near the facility. Okay, somebody pick it up and plug in into their computer. Yeah, free USB key, right? So then they compromise the Windows system running those industrial computer. Okay, so the industrial computer are actually often running Windows system. So because the systems are air-gapped, it means that more often than not, it's not up to date. Okay, it's not patched. So the Stuxnet actually using some 0 days because this is a very important target. So they're actually using 0 days to target those computers. So instead of causing incident and being caught, so the Stuxnet malware will gradually increase the consumption of raw material. So if you think about it, right? So they have limited supply of raw materials. So if they increase the consumption of raw material, they can stealthily foil the effort to create a nuclear bombs. Okay, they can also do the server-side attack, for example, to steal the financial data, like credit card numbers. So here are some examples, like in the targeted attack in 2013, there are 140 million credit card numbers stolen. So the targeted attack is actually very interesting. So if you think about this, right? So the credit card number are actually stored in the POS system, the point of sales. Their system to run their cash machine, right? But the way they get into their system is through the HVAC. So for the air conditioning system, the HVAC is actually connected with the POS system. So through the HVAC system, they can launch an attack against the financial data. So there are many similar attacks, like Home Depot also had a major leak. Okay, it can also be politically motivated, or by infecting the visiting user, something we call the waterhole attack. So the waterhole attack, everybody knows what is a waterhole, right? In Africa, there are only very few places have small holes of water. So all the animals will come here to get water. So if you are a predator, what you can do is just wait here. For the animals to come to get water, right? So this is why it's called a waterhole attack. So if you can compromise a website, you know your target frequently visiting this website, you can launch the attack by waiting on this compromised website. Okay, so let's quickly talk about the vulnerability marketplace. So the actually vulnerability there are several options. The first is a bug bounty program. So the bug bounty program, basically the software vendor will say, we will pay you instead to fix the problem later some money if you gave us your exploits. Okay, so normally this is a more exploit reward program, because they want you to have a working exploit to demonstrate the vulnerability. So the Google Vulnerability Reward Program up to $100,000. Microsoft also up to $100,000. Mozilla $500 to $300. So the Pwn2Own competition is $15,000. So the Pwn2Own is a hacking competition. Basically, they have a number of fully patched computers. Okay, if you can demonstrate you can compromise those fully patched computers, you can get a reward. So they have targeted like Windows, Chrome browser, like Edge browser, Firefox browser, a lot of browsers. Sometimes they have Tesla. Tesla actually has a very advanced computer inside, right? So you have a big touch screen. You can control a lot of parameters. And electronic voting system. Okay, so and also say VMware, the hypervisor, right? There are all kinds of different targets. So the key, those systems are fully patched. So they are asking to demonstrate 0 days. Okay. So normally those vendors will hold on to their patches. Okay. So for example, Microsoft will hold on to their patches, and right before the event, they are going to release their patch. Now, some of the 0 day, those hacks they have will become ineffective because they just released their patch, right? So you can also sell to a ZDI defense. So, but the third option is the black market. So this is really not an option for ethical hackers, right? So for example, if you have vulnerability for Android, you can fetch from 30,000 to 60,000. If you have a vulnerability in iOS, you can fetch between 100,000 to a quarter million. Sorry, this is the data from 2013. So because of the years, those vendors have improved their security dramatically. So the price for the vulnerability will actually go up. Okay. So if you think about it, right? So if somebody buy your vulnerability for $250,000, so what are they going to do to get this money back, right? So it's not a good idea to send this to in the black market. Okay, so there is a marketplace for the owned machines. So something we call the pay-per-install services. So it will install client's malware on the owned machines for a fee. So here we have a figure for this, right? So this is the target host. This is the owned machine, right? So this is the machine owned by some poor guy. Then somebody compromised this machine. So it's going to install an installer. So now, so those clients, so the clients will provide a malware. So this malware can profit from those compromised machines. Okay, so they are paying a fee to this guy. So this guy is called a bot master. So he is running the botnet. Okay, so the bot master can install their malware into the botnet he or she owns, right? So by doing so, they're going to pay those clients will pay a fee to the bot master. But the bot masters actually have some affiliation or affiliate. So they work with each other. So they are going to increase the install base of their client software, right? So more installation means more money for the bot masters. Okay, so for the US, so it will be $100 to $180 per 1,000 machine. In Asia, that will be $7 to $8 per 1,000 machines. Okay, so the price of this installation is really dependent on the country, right? So the richer country get charged for more because they expect to profit more from those bots. Okay, so if you look at this, right, today's cybercrime is not a single person effort. It's more a team effort. Okay, it's like a pipeline. Okay, you have some people to write exploits. Okay, so those people will sell their exploits to the board masters. Okay, so the board masters use those exploits, compromise machines, and build a bot. Right? So now they have this huge botnet. So there are also some people to write malware. They are going to sell this malware to those malware operators. So these malware operators will pay these bot masters and install their malware onto those bots. Okay, so even inside the malware, right? So there are actually a lot of collaboration. For example, some people will provide a service for obfuscation. Or obfuscation as a service. So the attacker or the malware writer will use this service to obfuscate their malware. So every time you given a piece of malware to this service, it will return equivalent malware, but in a very different encoding. Okay. Okay. In this course, be aware of the exploit technology. Learn to defend and avoid the common exploits, and also learn to architect a secure system. So this is a textbook we have mentioned in the welcome lecture, right? So you can also buy the computer and internet security hands-on approach, all for the second edition. Okay, don't buy the first edition. Okay, let's stop here.